In the diagram, PR and QS intersected V, and also W is on PV. U is on PS, and T is on PQ, and Q is on Q and ST passing through W for some real number X. If the areas of PUW are 4x plus 4, SUW is 2x plus 20, SVW is 5x plus 20, SVR is 5x plus 11, QVR is 8x plus 32, and QVW is 8x plus 50, what is the area of PTW? Before I begin this question, I'd like to give a little bit of a primer to illustrate some very important fact. And once you have that fact, it will make a lot more sense as to what the question is all about. So let's say we have a triangle, and that triangle has a base, and that base is in some ratio. It doesn't really matter, but let's just say it's in some ratio. We'll call this A, we'll call this B, and we'll call this C. Now I said to you, figure out what is the ratio of the area of this to the area of that. Okay. The first thing I need to do is draw an altitude. So I'll draw an altitude that's perpendicular to the base, and we'll call that height. So the area of AB, and we'll call this D, I guess, ABD, over the area of BCD. First, let's do it the long way, 1/2 base times height. So the top would be 1/2 base, which is AB, times height. The bottom is 1/2 base, which is BC, times height. It has the same height. And if you notice, the heights and the halves cancel, so you just have AB over BC. So in any kind of situation like that, all we really need to do to figure out the ratio of the areas of the triangles is look at the ratio of the bases, AB over BC. And that's it. If we were told the ratios, like if I was told that this AB is equal to 2 and this BC is equal to 1, then it becomes even easier, 2 over 1. So that is the primer I wanted you to learn about. So now let's tackle this guy, and of course I'm going to blow it up a little bit. Alright, here we go. Let's put it in the diagram, 4x plus 4, so 4x plus 4, and then 2x plus 20 is this guy here, 2x plus 20, and then 5x plus 20 is this guy, 5x plus 20, and then 5x plus 11 goes here, and then 8x plus 32 is here, and then there's one more, right? 8x plus 50. Okay, we're not told anything about that. We're not told anything about that. So I'll just call them something. I'll call this one M, and I'll call this one N. So this question is essentially telling me to find PTW, which would be find N. This is my task in the question. All right, here we go. And just like the primer, this triangle over that triangle is equivalent to the bases, QV over VS. So when you add it up, what do we get? Well, before I even include M and N, I think it's just easier to just include these ones since we already have. So I'll just do it with that. So QVW over this 5x plus 20, which is SVW, is going to be the same as QV over VS, right? Just like the primer. So QVW over SVW is the same as QV over VS. But QV over VS is also applicable to these guys down here. They're just upside down. And those triangles are QVR and 5x plus 11, which is represented as SVR, right? Okay, so now we can use this and this to make an equation. So that will be 8x plus 50 over 5x plus 20 is equal to QVR, which is 8x plus 32 over SVR, which is 5x plus 11. And then cross multiply, and when we do, we get 40x squared plus 88x plus 550x plus 250x plus 550. And then the other side is going to be 40x squared plus 160x plus 160x plus 640. And when you do that math, you get 338x plus 550 is equal to 320x plus 640. So that means 18x is equal to 90, and therefore x is equal to 5. Great, x is equal to 5. So now, all of these we can figure out in terms of numerical values. This is going to be 24. This is going to be 30. This is 45. This is 36. This is 72. And this is 90. Great. Okay. So far so good. Now let's move on to the next thing, which is involving the M's and N's. All right. Well, I think it would be very helpful if I actually knew some numbers. If I knew some numbers, that would really help me out. But do I? And the answer is sure. Why not? QV over VS, we can easily get a number for it. It would be 90 over 45, right? We already have the equation. QVW, we just figured out, was 90. And SVW, we just figured out, was 45. So QV over VS looks like 2 to 1. There we go. This is 2 and this is 1. So I'll just write that here, QV over VS. So that's a very important finding. And now we can use that to figure out some very important details. So that basically means that this triangle over this triangle would be 2 to 1 in its ratio because it's equal to QVS. So PQV, that big one, over PVS is the same as QV over VS, which is 2 to 1. So PVQ, it looks like M plus N plus 90. And then PVS is 24 plus 30 plus 45. And that's 2 to 1. All right, that's pretty good finding. And that looks like M plus N plus 90 is going to be, if I cross multiply, 24 plus 30 plus 45 is 99. Times 2 would be 198. So that means M is going to be equal to 108 minus N. All right, great. And I think we have just one more step to go and we'll get this. And that final step, I think, is to just look at the ratio. But in a slightly different way. We're looking at it from that angle being the base. That this is the base now. This over that is the equivalent of QT over PT. But we can also write this over that is QT over PT. So I think all I need to do is just use this fact and that diagram. So M is equal to 108 minus N, and this diagram should be sufficient. So M is equal to 108 minus N. Okay, now let's figure this out. M over N is the same as the bases QT over TP. But I can also use the big triangles, which would be TSQ over PST. And there you go. That should be enough for us to figure out M and N. And our goal is, of course, to figure out N. Okay, here we go. So since I'm interested in just in N, I'm going to use M is equal to 108 minus N over N. And then this part here, I can just get from the diagram TSQ. That's going to be m plus 90 plus 45. And PST from the diagram is n plus 24 plus 30. Okay, so 108 minus n over n, and the m, of course, I'm just going to substitute that 108 minus n plus 135, and this is n plus 54. All right, cross multiply now, and when I do, I get 108 minus n times n plus 54, and this is n times 243 minus n. And then this will become 108n plus 5832 minus n squared minus 54n. On the other side, 243n minus n squared. The n minus n squareds cancel, so that's great. I don't have to worry about any quadratic. And if I collect like terms, I'll get 189n. And then finally, n is 5832 divided by 189. When you do that, you get about 30.8. All right, 30.8. That was what I used to represent PTW, and therefore its value is 30.8, and that is closest to 31. Number 25, the answer is E. Two circles each have a radius of 10. They overlap so that each contains exactly 25% of the other's circumference, as shown. The area of the shaded region is closest to. I would like to make this a bit bigger, since this diagram is at the heart of the question, and I think that's sufficient. Okay, so the first thing I want to draw is the center of this circle, and I'll draw lines to that point and lines to that point. Now, this piece of information is important. They overlap so that they each contain 25% of the other circumference. So that means this segment represents 25% of the total circumference all the way around, like that. What that basically means, the interpretation of that, is that this angle is 25% of the total angle. Now the total angle all the way around is what? 360, right? So this angle right here has to be 25% of that. And if you do that math, you get 90 degrees. And that's why I put a little right angle there. So now we are in a better position to calculate that shaded region. First thing I'm going to do is drop a line to cut that shaded region in half. And when I do, I will label one of that shaded region A. And that's A and that's A. So I'll just leave that labeled as A, and therefore the shaded region is the equivalent to finding 2A. First we'll calculate A, and then you can just multiply it by 2 later. So how do we calculate A? A is calculated as follows. First and foremost, you take this area, which is sort of that pi segment, right? And that pi segment is basically the area of the circle divided by 4. It's a quarter of the circle. That's what that 90 degrees helps us to determine. Once you find that pi segment, from it, subtract this triangle. If you do that, you'll get A. Now, how do you figure out the area of that triangle? Well, it's 1/2 base times height, like that. And I think most of these things we know. So pi, obviously we know r is 10. And then 1/2 base times height. Well, the base and the height, if I call this, say, the base and the height, both of those are the radius. So one is 10 and the other one's 10. And that's it. So this is going to be 25 pi minus 50. And that's A. Now, of course, I want to figure out 2A because the area of the shaded region is 2A. So that's going to be 2 times that, which is obviously 50 pi minus 100. and that is equal to approximately 57. And of the answer choices, the closest is choice A. Chuck the llama is tied to the corner of a 2 meter by 3 meter shed on a 3 meter leash. How much area does Chuck have in which to play if he can go only around the outside of the shed? So let's draw this again here. So here we go. This is the shed approximately. And here I'm going to draw the leash like that. Was it 3? Yeah, 3 meters. So how can that leash move? Well, I'll show you. This is the leash, right? So he goes like that. That's his only way to move. And then when he gets to here, he can't go like that because he can't go inside the shed. So at this point, he can only go like this. So basically what that does is it forms the components of a circle. And I'll draw in those circles. So here we go. I've tried to draw the area the best I can. So he's basically going to be able to move all the way like that. And then once he gets to that point, he can only move this much. So we have to now figure out that total region. Well, it looks like it's 3/4 of a big circle. So 3/4 pi r squared plus 1/4 of a small circle. So 1/4 pi small r squared. This is the total area in which he can play. So 3/4 times pi, the big R is 3. And 1/4 times pi r, the small r, well, the leash is 3. This distance is 2. So that means this distance is 1. So that is what the small r represents, a distance of 1. So here we go. 9 times 3, 27 pi over 4. And this looks like just pi over 4. So it looks like 28 pi over 4. And that is 7 pi. So number 22, the answer is A. A farmer has a rectangular field with width 45 meters. He divides the field into smaller rectangular animal enclosures in 3 different sizes as shown. Each enclosure labeled A1 has the same dimensions. Also, the area of the enclosure labeled A2 is 4 times the area of A1, and the area of enclosure labeled A3 is 5 times the area of A1. The lines in the diagram represent fences. The total length of all the fences is 360 meters. The area of A1 in square meters is closest to. Let's label this X, X, and X, and then this will also be X, those little guys, like that. And then this side will be 3X from here to here. And then we will label these side parts Z and Z, but this part I don't know yet, because that's not going to be Z. And then therefore, this is going to be Z, and that's going to be Z. This part from here to here I will call Y. And this part, of course, is also Y. And then this part I don't know yet, because I have to first concentrate on figuring out that. Okay, well, we'll just call that W for now, for W for width. And let's take a look at our first piece of information, which is that A2 is equal to 4 times A1, given to us in the question. Well, A1 in terms of its area will be X times Z, and A2 in terms of its area is 3X times W, correct? So the X's cancel from both sides. You're just left with 3W is equal to 4Z, and therefore W is equal to 4Z over 3. So put that in here, 4Z over 3. So if I add all these guys up, it'll be Z plus 4Z over 3. And if you add that up, you will get a sum of 10z over 3. So this top to bottom is 10z over 3. So there we go. And I think that's pretty much all the dimensions for now, just with A1 and A2. So now we will concentrate on the next piece of information, which is A3 and A1. They tell me that A3 is 5 times the area of A1. Okay? Well, what is A3? In terms of our dimensions, it would be y times 10z over 3. And 5A1, well, that's just xz as before. Okay, let's see how far we can go. The z's cancel from both sides, so we're just left with y is equal to 10 over 3 is equal to 5x. And then y, therefore, would be 15 over 10x. And therefore, y will be 1.5x, like that. All right, so that's a pretty good start. Now, where do we go from here? Well, now what we have to do is take into consideration the whole business about the fence. That fence is equal to 360 meters. And we also can take into consideration that 45 up there that they gave us. So from the 45, that means that 3x plus y is 45. And that's a pretty helpful piece of information, because now we can substitute this into that equation I just drew. So that's going to be 3x plus 1.5x is equal to 45. So that means 4.5x is equal to 45. Therefore, x is 10. And therefore, if x is 10, I can substitute that in here. Therefore, y will be 1.5 times 10, which is 15. All right, great. And now we have to figure out z. How we figure out z is by using, of course, this part, that the total fence is 360. So we have to now figure out what is the total fence. Okay, first let's concentrate on the x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 3, 12 x's make up part of that fence, so we have 12x. Now let's concentrate on the z's. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I've got 8 z's. And then I've got these two guys here that were 4z over 3, so 2 of those guys. So 2 times 4z over 3. And then I've got 2 y's, and then I've got this 10z over 3. So plus 2y plus 10z over 3. And all of that is equal to 360. Okay, so I think I can figure this out. Let's just do this basic algebra. Well, we can substitute in these guys. That will be very helpful for us. So that will be 12 times 10, which is 120. 8z, well, z I don't know. This is 8z over 3. 2y, that's going to be 2 times 15, so 30. 10z over 3, and then that's 360. So let's add these here. We got 18z over 3. Well, that's just 6z. So 8z plus 6z, and then put all the numbers on one side. 240, 210 is going to be that number. So I've got 14z is 210, and therefore z is 15. Yeah. All right, let's figure out now the final thing, which is the area of A1. The area of A1, that's our final task, is x times z. Well, x is 15. Z we figured out to also be, x is 10. And z we figured out to be 15. So therefore 10 times 15 is 150. And that's the answer. So number 21, the answer is B. An 8 by 8 by n rectangular prism is made up from 1 by 1 by 1 cubes. Suppose that A is the surface area of the prism and B is the combined surface area of the 1 by 1 by 1 cubes that make up the prism. What is the sum of the values of n for which b over a is an integer? I will first start off with a simple example. Let's say n is 2. And hopefully this example will make you understand how to approach this question. So in this case, if n is 2, it will be an 8 by 8 by 2 dimension rectangular prism. And that area is 128. Now it's made up of these unit cubes. Each has an area of 1. So it'll be 128 unit cubes in this scenario. Now the surface area, which they are calling A, of the prism will be as follows. It'll be 2 times 8 by 8 plus 2 times 8 by 2 plus 2 times 8 by 2. So I just drew what it could look like, that prism. Okay, so let's figure this out now. This would be, in terms of numbers, 192. Now let's figure out B, which they are calling the combined surface area of the unit cubes. Well, there's 128 of them, and each of them would have a surface area of 6, since it's just basically a unit cube with each side being 1 by 1. So there you go. So that would mean 128 times 6 is 768. So what is B over A in this case? B over A would be 768 over 192, and that is 4. Is that an integer? Yes. So that is how we approach this question. Now let's do the exact same thing, but instead of n being 2, n is just n. So now we have 8 by 8 by n, and that is 64n. That is the number of unit cubes that make up this particular prism. Our surface area of the cube would be 2 times, again, 8 times 8. That's the bottom of the base of the prism. Then it'll be 2 times 8 times n this time, plus 2 times 8 times n. So this is 128 plus 32n. Okay. Now B, well, that's very easy. That's just going to be the number of unit cubes, which is 64n, times 6, which is just 384n. Okay, so now what is my B over A? It is 384n over 128 plus 32n. I think I can divide through by 32, and when I do, I get 12n over 4 plus n. All right, so this is very, very nice. I think I can work with this without too much problem. I've got to start plugging in values of n so that this becomes an integer. Okay, I'm sure I can do that. Let's make a table and proceed. So we got n, and then we have 12n over 4 plus n. So this is, at this point, just plug and play. Let's try 1. When you get 1 for n, you get 12 over 5. Is 12 over 5 an integer? No. You try 2. That's 24 over 6, and that is an integer because that is equal to 6. So we circle that. That was actually the one I did in the example. I used n equals 2. So we know that's going to be an integer. And you just keep going like this. 3, and it's going to be 36 over 7. That's not an integer. And then 4. 4 is 48 over 8, and that is an integer. It is equal to 6. So circle 4 as a value for n. And you just keep going like this. So I'm not going to bore you by going through every single one. I'm just going to write the ones for which this becomes an integer. And it is time consuming, but that's the way it is since it's number 25. 8 works. It gives you 96 over 12, which is equal to 8. And therefore, that works in terms of giving you an integer value. The next one that works is 12 for the value of n. It gives you 144 over 16, which is equal to 9. 9 is, of course, an integer. The next one that works after a lot of numbers that don't work is 20. You have to get all the way up to 20. 240 over 24, and that's 10. And then you get really painful. You've got to keep trying until 44. to get the next value of n. And that gives me a integer value of 11. And at that point, it's finished, thankfully. And now you just have to add up the values of n that worked. So 2 plus 4 plus 8 plus 12 plus 20 plus 44. And that's 90. So that is the answer. And that's B. Now you might say, well, how do you know that you have to stop at 44? Why didn't you just keep going here, 45, 46, and so on? Because if I did, my sum would be greater than 90. It would be much greater than 90. It would be at least 45 greater than 90, and there's no answer choice that is that big. So you can be confident that 90 is indeed the right answer. So number 25, that would be B.